Hi, I'm Jake. I focus on special projects here at DataRobot, and today I'm going to be talking to you about what makes a good machine learning use case. Many organizations understand that it's important to use AI in their business. However, they also struggle with identifying good opportunities and understanding the right problems that AI and machine learning can successfully solve. This checklist constitutes 4 main questions. First, do you know what you want to predict? Next, is there any historical data to work from? And it's important that that data has measurements of what you want to predict. Next, what changes will be made by having a prediction? And finally, what impact will this actually have? Let's start with knowing what it is that we even want to predict. You have to understand what problem you're trying to solve in the first place. By knowing the problem that we actually want to solve, we can help narrow the focus and also be able to solve the right problems for our organization. Let's use the example of a higher education university, and the problem that they're facing is students are not graduating at the rate that they would prefer, and many students are also not completing their degree. Do we know what we want to predict would constitute, do we know which students are most at risk of not completing their degree? The university wants to be able to successfully predict and identify which of its students have the highest risk of not completing their degree. By answering this, we now know what we want to predict, which is which students are at risk of not graduating and completing their degree. Next, we have to evaluate whether there's any historical data to work from. The data needs to include measurements of what it is that we want to predict. Otherwise, we're going to be attempting to predict things that we've actually never observed. Using the higher education example, the historical data set that we then use to train the machine learning model would probably look something like this. We'd want to know historically which students actually graduated as indicated by our alumni column here, and then what are the different measurements that related to or not to their graduation. Once the university understands which of its historic students graduated and did not, it then has a data set it can create in order to work from and train its AI model. Next, we need to ask ourselves, what changes will be made by having a prediction? Having a prediction is actually not all that important because the prediction in and of itself is not all that valuable. It's important to be able to take action based on the prediction and thus introduce change to an existing process. In the case of the university, an at-risk student might be assigned tutors, mentors, counseling, office hours, or other forms of support in order to help bring down their risk of not graduating and prop up their chances of successfully completing their degree. By understanding what changes we can enact at the organization based on the prediction, the university now knows how to intervene and take action from their prediction. Now lastly, we want to understand what sort of impact are these changes and is that prediction going to have on our organization. The most obvious will be fiscal, driving additional revenue or decreasing costs, but we can also experience gains through productivity and brand awareness. For the university, they want to make sure that they can measure whatever sort of impact they're going after. And for them, key metrics would include things like increased graduation rates as well as increased alumni donations. So for the university, measuring the increases in alumni graduation rates and donations indicates to us what impact this change is going to have. Identifying key opportunities to implement AI is difficult if you don't know the right questions to ask. But by using a checklist such as this and other resources at their disposal, each organization now has a better chance of being successful with AI. And that's how you identify a good use case for machine learning.